Projectiles with upward VI. So we've talked about examples where our projectiles are just fired horizontally, and therefore when they do their path, they're not going at an angle, they're not starting with a vertical VI, it's just a horizontal one, a VX. So in this case we have a VX and there's no VY. But what we're going to be talking about now is projectiles with an upward VI. So in this case, instead of going horizontal, our projectiles are going to be fired up at an angle, say 30 degrees. So an upward VI means that the projectile's initial path is at an angle above the horizontal and does not equal zero. Projectiles travel with a parabolic trajectory because the downward force of gravity accelerates them downwards from their otherwise inertial motion. So you can see in the diagram at the bottom here, we're going to have an initial VI that goes like this, and that's going to cause our object to follow this path here and eventually come down. And the reason it comes down is because we have the force of gravity causing it to come down at a rate of 9.8 meters per second squared. Analyzing more complex projectile motion problems. So when our VI y is equal to zero, it's pretty basic, it's very straightforward. But when our VI y is not equal to zero, that's when things start to get a little bit more difficult. Now the same kinematic equations can be used to analyze problems where the initial velocity is at some angle to the horizontal, as in VI y is not equal to zero. Often you need to break these problems into different sections to take into account the upward and then downward motion. You will then need to use vector components to find the velocity values in the x and y directions. So an example. So you can see here our projectile starts here at the bottom, and it's fired with an initial velocity of 15 meters per second at an angle of 30 degrees above the horizontal. So in this case, we can break our initial velocity into its vector components. So our VI is 15 meters a second. Our VIX is going to be 15 cos 30 because it's the adjacent side. So that's cos. So 15 cos 30, and that equals 12.99 or 13 meters per second. And then our Y value is going to be, in this case, it's going to be the opposite. So it's going to be 15 sine, because it's opposite, 30, and that equals 7.5 meters per second. Now you're going to be asked about different things like max height. Max height is right here, right when the projectile reaches its topmost point, its maximum height, and this is at the midpoint. At this point, it's actually right in the middle. So the time here, call that time 1, is going to equal time 2. However long it takes to go up is going to be the exact same amount of time it takes to come down. So there's going to be different tricks that we can use to find our solutions in these problems. But if you were to find time to max height, and you were to double it, that would equal our total time. Now, if you were looking for something like range, that's going to be our dx. Our dx is going to equal to vx times time. And if you know vx, because vx will not change, in this case, it's going to be 12.99 meters per second for the entire duration of the flight. So we could plug that in. So we could say 12.99, and let's just say we found our initial time. Let's say t1 was 3 seconds. Well, then t total is going to be 6 seconds because you have to go up and then come down. And then you can get a maximum range for this particular motion. So there's a couple little tricks we can use. The questions aren't that hard, but they do get a little bit more difficult and they're a little bit more complex. So let's try one out. Check your understanding. A soccer player running on a level playing field kicks a soccer ball with a velocity of 9.4 meters per second forward at an angle of 40 degrees above the horizontal. Determine the soccer ball's time of flight, range, and maximum height. So the first thing we need to do is we need to draw out our situation. So I'm just going to draw our field. Here's our projectile. It's going to be kicked at an angle of 40 degrees. And after it's kicked, it's going to follow this motion, and it's going to go like that. This is going to be our range, our dx value. This is going to be our max height. In that case, it's going to be our max dy value. We know that a velocity initial is 9.4 meters per second. When it gets to the top, another little trick to keep in mind is that it's vfy at the top is going to be 0. It is not moving up or down at this point. It's stationary in the vertical. It's still moving, of course, horizontally, and it's actually going to be moving horizontally at the same rate for the entire duration of the motion. So if we have Vix over here is going to be a component of 9.4, so it's going to be 9.4 cos 40, which is equal to 7.2 meters per second. So the velocity in the x direction is 7.2 meters per second at the beginning. It's 7.2 meters per second. So that's Vx at the top. And at the bottom, it's still 7.2 meters per second. So let's take a look at this question. So this question asks for our time of flight. Well, to find time of flight, we can find time up, and then we can multiply that by 2. So how do we find the time up? Well, let's figure out what we know so far. Our VIY is going to be this guy right here. It's going to be a component of that initial. So it's going to be 9.4 sine 40, and that equals to 6.04 meters per second. And don't forget, we need to say right and up are positive to make our question and our numbers valid. What else do we know? Well, we're looking for time. So time up. The distance up, we also don't know. Acceleration, now acceleration would be working down. We said up was positive, so acceleration would be negative 9.8 meters per second squared. But also we know that VFY at the top is 0. So VFY is 0. So now we have 1, 2, 3 components, and we're looking for time. So we can solve this problem, but we need an equation to do so. Let's use A equals VF minus VI over T. We're going to rearrange. We're going to say T is going to equal to VF minus VI over A. And we're going to plug our numbers in. We know that VF at the top is 0, minus 6.04 divided by negative 9.8, and that equals to 0.616 seconds. So our total time is going to equal to 0.616 times 2, which equals to 1.23 seconds. So that's our total time, the time it takes to go up, and then the time it takes to come down combined. So that gives us our total time, the time it takes to go up plus the time it takes to go down. So that's A. So A, 1.23 seconds. We need 2 sig digs, and technically we need 1 with this 40. But let's use 2 to make the question a little bit more realistic. 1.2 seconds. That's our total time. Now range, that's going to be our dx. Now to find dx, we're going to take Vx times total time. Our Vx is going to be this number that we came up with before, the 7.2. 7.2 times the total time, 1.23, and that equals to 8.86 meters. Now, of course, we need 2 sig digs like we were talking about before, so we're going to say 8.9 meters. So 8.9 meters. And now the last thing we're asked for is the maximum height. So let's make a little bit of room here. So maximum height, that's our dy. So now we got to find dy. dy, that's our question. We know our time to go up was 0.616 seconds. We know our VIY was 6.04 meters per second. We know our VFY is 0, and we know our acceleration is negative 9.8 meters per second squared. So now we can really use any equation we like. Let's use d equals VIT plus 1/2 AT squared. VIY 6.04 times time to go up 0.616. Now we're only using the time to go up, not the total time. Keep that in mind. Plus 1/2 negative 9.8 times 0.616 squared. And we put that into our calculator and we get 1.86 meters. Now we need 2 sig digs, so we're going to say 1.9 meters. So our maximum height, 1.9 meters. And we're done. Check your understanding. A golfer is trying to improve the range of her shot. To do so, she drives a golf ball from the top of a steep cliff 30 meters above the ground where the ball will land. So let's draw that out first. So we got our cliff, and we're going to take our ball, and we're going to shoot it from right here. We're going to fire it at 25 meters per second at an angle of 50 degrees, as the rest of the question states. There's 25 meters per second at an angle of 50 degrees. Now the height of this cliff, as it says, is 30 meters above where the ball is going to land. So now in this case, a little bit more complicated because the ball's going to go up. It has to come all the way down here for it to land. So it's going to make our problem a little more complicated. So A says time of flight. Well, to find the time of flight, we need to have time up plus time down. So we need a lot of information in order to solve this particular problem. So first of all, let's find time up. So time up, that's our question. We don't know distance. We'll call that distance max. We don't know distance max. VIY, we do know, because it's going to be 25. It's opposite. So we're going to say sine 50, and that equals to 19.2. And we know VIX, that's going to equal to 25 cos 50, which equals to 16.1. We know acceleration is going to be negative 9.8 meters per second squared, because we're going to say right and up are positive. Therefore, acceleration is negative because it's going down. And we know at the very top, VFY is going to equal to 0 meters per second, because it's not going to be moving in the vertical direction at the top. So now what we need to do, we need to solve for time up. We need to solve for D. So there's a bunch of things we can do. So let's find time up first. So time up, that's going to be our question. And we're going to use A equals VF minus VI over T. We're going to rearrange T equals VF minus VI over A. VF we know is 0. We know VI was 19.2, and acceleration is negative 9.8. So we get 1.96 seconds. So that's the time to go up. Now we can't just double that because now, of course, we're falling these extra 30 meters. So that's only the time to go up. So now we've got to find the time to come down. Well, we can't figure that out until we know how far it's going to fall. So let's find D max, because we've got to find out how high it's actually falling from, right? That's going to be our D max value right there. So let's use VF squared equals VI squared plus 2AD. That's just one of our main 5 equations. VF squared we know is 0. VI squared we know is 19.2 plus 2 negative 9.8 times D. So let's expand this out a little bit. So we have 0 equals 368.64 minus 19.6D. We're going to move the 19.6D to the other side of the equation. So we're going to get 19.6D equals 368.64. We're going to divide both sides by 19.6, and we're going to get a D value of 18.8 meters. So that's our max height. So now we can solve for the time to come down. So we know at the very top, so right here at point number 2, so point number 2, the distance that it's going to fall is going to be the 30 meters initially plus the 18.8 meters that we just found, and that equals to 48.8 meters. So that's the total drop. The time to fall is the question. The VIY we now know is 0 because starting at the top, remember the VF previous is now the new VI, so the VIY is 0. Acceleration is going to be 9.8. I'm going to tell you why in a second, because of course now we have a new set of equations. So we were using right and up as positive, but now what we can do is we can actually change that. Now we can make down and right positive. And the reason we can do that is that because we're using a new set of equations, a new formula. It's kind of like we're starting the question over again. So now we can flip it. Of course, you can keep right and up as positive, and then your A value is going to be negative, but then your D value is negative. Everything just becomes a little bit more difficult. So since now we're changing equations, we're pretty much doing a second set of equations, let's make down and right positive to make our math a little bit easier. And now we have all the information that we need. So let's use the equation D equals VIT plus 1/2 AT squared. We know VI is 0, so that goes away. We're left with 48.8 equals 1 over 2, 9.8 T squared. Now to get T on its own, we're going to take 48.8 and multiply it by 2, because you multiply the right side by 2 and the left side by 2. And then we're going to divide by 9.8, because what you do to the right side, you do to the left side. So to get T squared on its own, we're going to do that, and we're going to get T squared equaling 9.96. Now when we take the square root of both sides, we get a T value of 3.16 seconds. But we're not done quite yet. That's the time to come down. So that's 3.16 seconds. The time to go up we found was right here. So we have 1.96 seconds. Now the total time is going to be the two of them together. And that equals to 5.1 seconds. And that is our final answer. So the total time of flight, 5.1 seconds. That's the time up plus the time down. B, what is the range? Well, that's actually a pretty easy question to answer. To find the range, that's dx. Dx is going to equal to Vx times t. We just found the total time, and we know Vx is going to be the component of the total velocity. So that's 25 cos 50. Now, it's easier to use this number. You put it right in your calculator, you're going to get an exact number instead of possibly making a rounding error. And we're going to multiply that by what we just found, 5.1 seconds. And we get 82.2 meters. We need 2 sig digs in our answer, so we're going to call it 82 meters. C. Now we need to find the final velocity just before it hits the ground. So if we zoom in, so taking a look at our picture, our initial picture right here, right? We're zooming in on this spot right there. So when we do that, it looks more like this. The ball is going to hit at some kind of angle. It's going to have a vertical drop, and it's going to have a horizontal component as well. So we need to figure these things out. The Vx, that's the horizontal, that's the one that never changes, right? That's going to be 25 cos 50. But we're going to need to find out this, the V final and the Y. That's unknown. So V final Y, we don't know. At the top of the flight, because remember, we're starting from the top. So essentially, since we're looking at the vertical component only, all we're really concerned about is that max height down to there. So I'm going to call that, I'm going to write max height So our VIY is 0 because remember, it's not moving at the maximum height, it's not moving up or down. So that's 0. We're going to state that down and right are positive. So we're going to use A is equal to 9.8. We know the time it takes to fall. That was 3.16 seconds. That's what we did previous, right? That was the second part that we added to the initial amount. And we know the distance is going to fall. We figured that out before as well. That's 48.8 meters. So now we have everything. So now we just need to find an equation to use. So let's use VF squared equals VI squared plus 2AD. VF squared is the question. VI squared is 0, right? 0 squared. 2 times 9.8 times 48.8. So we get VF squared equals 956.48. We take the square root of both, and we get a VF value of 30.93 meters per second. So that's 30.93. But we're not done yet, right? We need to find the hypotenuse, this guy right there. That is our final velocity. So final velocity is going to equal to the square root of 25 cos 50 squared plus 30.93 squared. And that equals to 34.86 meters per second. We need to know an angle. Theta is going to equal to tan minus 1, opposite, which is 25 cos 50, divided by the adjacent side, which was 30.93, and that gives us a theta value of 27.5 degrees. Now we said we wanted 2 sig dig, so our final velocity is going to equal to 35 meters per second. In our diagram, we went down 28 degrees right, and that's our final answer. Check your understanding. A princess trapped in a castle wraps a message around a rock and throws it from the top of the castle wall with an initial velocity of 12 meters per second, 42 degrees above the horizontal. The rock lands just on the far side of the castle's moat at a level 9.5 meters below the initial level. Determine the time of flight. So you're going to notice this question is almost exactly the same as the previous question. So we're going to work through it in the same way. So what do we know initially? Well, the VIY is going to be 12 times sine 42. And that equals to 8.03. The VIX is 12 cos 42, which equals to 8.92. We don't know how high it goes up initially, because this is the point right here between 1 and 2. So we'll call that 1. Okay. We don't know how high it goes up. We know acceleration is going to be negative 9.8 because we're going to say that right and up are positive at the beginning. And we also don't know time. And lastly, we know that VFY is 0 because at the very top is not moving in the vertical direction at all. So now we can use our equation A equals VF minus VI over T. We can rearrange. T is equal to VF minus VI over A. VF is 0 minus 8.03 over negative 9.8. And that gives us 0.82 seconds. So that's the time it takes to get up. So now we know from the previous question we're going to need to know max height as well. So let's work on that here. So let's just say that that's dy. That's our question. And we're going to use our same variables from before. So let's say that d is going to equal to vit plus 1/2 at squared. Vi we know is 8.03. We know the time to get up is 0.82 plus 1/2 negative 9.8 times 0.82. And that gives us a d value of 2.57 meters. So we know our total height, so going up to down, so I'll just draw it right here, that value is going to equal to 2.57 plus our 9.5, which equals 12.1 meters. So that's going to be our total height, so we know that. Okay, so now we need to know our time to come down. So that was time up. So we'll just write time up. So now we need to know time down. That's our question. And again, we can use the same variables. We know that the total distance that it's going to fall is going to be the number we just figured out, which was 12.1 meters. We know the VI now is going to be 0 because we're starting from rest at the top. And we know the acceleration is going to be 9.8. So just like we did before, we're now going to switch our equation around. We're going to say down and right are positive because we're using a different equation. So now we can make down positive. And we're going to use the same equation. So d is going to equal to VIT plus 1/2 at squared. We know VI is 0, so that crosses that out. The distance is going to be 12.1 equals 1/2 9.8 t squared. 12.1 times 2 is 24.2 divided by 9.8, and that gives us our t squared. Our t squared value is going to equal to 24.2 divided by 9.8, which is 2.47. We then take the square root of both, and we get a t value of 1.57 seconds. So now we need to know the total time. So total time, let's do it over here, right here. So t total is going to equal to the 1.57 that we just figured out, plus the time to get up, which was 0.82, which is equal to 2.4 seconds. And that's our total time of flight. B, the width of the moat. That's just the same way of saying the range. So if we go back to our initial picture here, the width of the moat would be right here, because the rock lands just on the other side. So that would be width right there. So essentially what we're trying to find in this question is dx. That's our question. We know that dx is going to equal to vx times the total time. Vx in this case is going to be 12 cos 42, and the time that we figured out was 2.4. We put that into our calculator, we get a value of 21.4 meters. To 2 sig digs is going to be 21 meters. Now the velocity of impact, and that's what we did on the previous question as well. So remember, when the rock is coming in, it's going to look something like that. And that's going to have a horizontal component and a vertical component. We already know the horizontal component. That's going to be our 12 cos 42. What we need to find is the VFY. That's our question. And once we know that, we can figure out the VF. So let's figure out the VFY. VFY, that's our question. We know the VIY because we're starting from the top. Remember, this is from the max height, the peak. So we know it's not moving the vertical direction. So that's going to be 0. We know the distance that it falls is 12.1 meters. We know the time that it fell was 1.57 seconds. And again, we're going to keep down as positive. So we're going to say acceleration is 9.8 meters per second squared. So how do we figure this out? Well, we need to use one of our equations, of course. So let's use VF squared equals VI squared plus 2AD. VF squared is our question. We know that is 0. 2 times 9.8 times a falling distance of 12.1 meters. VF squared equals to 237.16. We take the square root of both, and we get a value of 15.4 meters per second. And we're going to leave it at that. 15.4, there's no need to round. So now we can find VF. VF is going to equal to the square root of 15.4 squared plus 12 cos 42 squared. And that gives us a value of 17.8 meters per second. We can find theta. Theta is going to equal to tan minus 1, opposite, which is 12 cos 42, divided by adjacent, which is 15.4. And that gives us a theta value of 30 degrees. So our final VF to 2 sig digs is going to be 18 meters per second. And in this example, we went down 30 degrees right. And that's our final answer. And that concludes our lesson on projectile motion.